How the World Works by Cami and Zachary Zabala.
In this presentation, we are going to show you the way in which we have measured the world to be, and then some possibilities of how the unknown creates and shapes this beautiful world we call home. We will be delving into how we visualize this place and the limits in which we may do so. We will look at electricity and magnetism, both the laws which govern them, and then occulted knowledge that is hidden in plain sight. We will be using many tests and observations we have made and documented ourselves, along with others we have gathered from academia and content providers who have shared their research on social media platforms. In the end, we are hoping to share something with you that you did not already know, or at least open your mind to some new possibilities. As my favorite quote from Plato goes, those able to see beyond the shadow and lies of their culture will never be understood, let alone believed by the masses.
A fundamental limitation of perspective. First off, we will be taking a look at perspective and the limitations of not only our eyes, but any lens with a circular aperture. This covers most cameras and telescopes, along with the vision of every human being on Earth. All of these lenses share what is called an angular resolution limit, which simply means that once two light sources get close enough together, they will merge into one, blurring the image. This is all determined by the size of the aperture, or hole, which is allowing the light to shine through, like the pupil of your eye, for example. Here are some students from Brigham Young University showing how the aperture can create this effect at the same distance just by changing its size. Next, we will take a look at some observations I made along a long warehouse floor up to 460 feet. As you can see, as I back the camera away from the bucket lids, the bottom creates a mirroring effect. The mirror grows larger until the actual lid and its mirror image start to appear to merge together. Another, taken with a flashlight, also shows a mirroring effect followed by them merging into one and then completely disappearing into thin air. David Weiss has captured this with the sun while tracking it with a drone multiple times. This diffraction pattern we see here can be calculated using a formula known as Rayleigh's criterion, and with this we find the average human eye to be around 0.02 degrees. It is radians equals 1.22 times lambda, or the wavelength of light, over d, the diameter of the aperture. The part of the equation which we want to concentrate on is the d. You can see that with it on the bottom, the larger it is, the smaller the final result will be. With this formula I wrote, you can easily figure out how much will always be hidden along your horizon when looking out over a long distance. A minute, if you will. When a boat gets to only 3 miles away, right around when we are told it should be going over a curve, there is over 5.5 feet that the human eye cannot resolve. You can watch it go out of sight with your eye's vision, then use a lens with a much larger aperture and bring the whole boat back into view. This drawing will show just what is happening and why we can somehow magically see an object which was believed to have gone over a solid barrier horizon without raising our elevation. This is because the larger aperture, the smaller the angle that can be resolved, as the equation showed us. With the average human eye losing the whole boat except for the sail at this point, you can now see why the camera with a much larger aperture can resolve the whole image once again. This is a fundamental limitation of physics pertaining to any lens with a circular aperture. However, This calculation does not take into account any atmospheric distortions and can only become worse in reality, as it is regarding to a perfect nitrogen-oxygen-based atmosphere with no moisture or dust particulates floating about. In short, the appearance of boats going over a curve, the bottom of buildings being cut off, and the luminaries in the sky appearing to set can all be explained over a flat surface with the fundamental limitations of our eyes alone.
The gyroscope and the magnet. In this next segment, we will be taking a look at the forces created by gyroscopes and magnets, how they are applied to our devices, and finally, how they interact with each other. The gyroscope, invented in 1743 by John Searson, was first called the whirling speculum and was used to identify the horizon in bad weather. Today they are used by many without us even knowing it. Gyroscopes are used from navigation tools for aircrafts and ships, sensors in your cell phones and watches, all the way down to a child's toy you yourself may have had at one time. The special property they possess is that once spinning fast enough, the gyroscope will obtain its rigidity in space. This simply means that no matter which way you tilt or rotate its mount, the gyroscope will be unaffected and hold its position in space. It has been claimed that the mechanical gyroscope can detect the motion of the Earth using this phenomena, but many failures to do so have been documented by academia and truth seekers alike. In a version of Popular Astronomy from 1922, we found this by M.C. Mott-Smith. One must often wonder whether the authors of these texts really ever performed the experiments they describe. Where the divergency between theory and fact is so great, as in the case of the gyroscope, it certainly should not be dismissed with a vague remark or two about friction. While the theorist may care little about it, the practical man naturally wants to know why the actual gyroscope behaves as it does. The more sensitive fiber optic and ring laser gyros do detect a motion, but we are not certain what causes this phenomenon. The magnet. Like electricity, magnetism holds many secrets we have not yet uncovered. What we do know is that every magnet produces a magnetic field, which can affect the world around it in many ways. Magnets, which interact with many metals, are used much more than gyroscopes and are no stranger to most of us. From children's toys and holding up papers on the fridge to industrial purposes used to lift enormous amounts of weight. Some have even replaced the pencil and brush with little magnets to express their artistic talents. The uses for magnets are endless, and we still haven't fully unlocked all of its secrets. We will now look at an observation we made while applying a magnetic field to a super precision gyroscope at rest, compared to one in motion at different speeds. When we hold a magnet near the motionless gyroscope, you can see there is a slight attraction only when one of the poles of a strong magnet is facing it. This is unusual, as brass and aluminum aren't magnetic in nature. The strangest thing is that once spinning at high speeds, the magnet will repulse or push the gyroscope away. This can be attributed to Lenz's law and shown in this quick demonstration. The magnet's descent is slowed as it passes through the brass pipe due to a current being created in the brass. This current then produces its own magnetic field, which interacts with the magnets. The question is, could these fiber optic and ring laser gyros be picking up the movement of the ever-changing magnetic field?
Electricity and the electric field. We could be here for days discussing electricity and what we as human beings have discovered so far on the subject. Instead, I will let Walter Lewin, former MIT physics professor, put in few words the importance of understanding electricity and how crucial it is to continue to investigate the subject further.
Electricity and magnetism is all around us. We have electric lights, electric clocks, we have microphones, calculators, televisions, VCRs, radio, computers. Light itself is an electromagnetic phenomenon, as radio waves are. The colors of the rainbow in the blue sky are there because of electricity, and I will teach you about that in this course. Cars, planes, trains can only run because of electricity. Horses need electricity because muscle contractions require electricity. Your nerve system is driven by electricity. Atoms, molecules, all chemical reactions exist because of electricity. You could not see without electricity. Your heart would not beat without electricity. And you could not even think without electricity, though I realize that even with electricity, some of you may have a problem with that.
As you heard from Professor Lewin, electricity governs how we perceive this world around us, and furthermore, the world itself. This is the electric field of the Earth and starts at the ground with a negative charge, obtaining more of a positive charge from above, increasing with elevation. We know from measurements that the electric potential in the air increases with altitude. Starting at 100 volts per meter just above the surface, increasing that same amount with every meter gained in elevation. So just above 2 meters, or 6.5 feet, there will be 300 volts of electricity in every cubic meter of air. You may think this is a large amount of volts to be floating just above our heads, but it takes 3 million volts per meter to have an electrical discharge occur. We will now take a look at some observations we made to see what we could achieve by creating and manipulating our own electric field and placing different substances between it. In our first test, we simply charge up 2 metal plates, making one positive and the other negative using a Van de Graaff generator. You can see in the demonstration that by simply switching the positive and negative charges of that which we find here on Earth, we can get very light objects to rise up from the positive plate below and stick to the negative plate above. We do not believe that this itself causes gravity, but may be what gives it its direction as far as up and down. In this next demonstration, we are going to take a look at what the electric field can do to the surface of water. We have a spherical object painted with metallic paint and held up by a wooden insulator with the Van de Graaff generator beneath. When a charge is applied, the water takes the shape of the electric field at its surface. This reminds me of this map created long ago using the stars as its reference. Now we will look at the nature of the electric field and why it must bend and curve between two objects that aren't perfectly parallel. When it comes in contact with the surface of any object, it will always be perpendicular to its surface. This simply means it will be touching the surface at a 90-degree angle, as you see here in this picture. All in all, electricity governs not only our senses, but the physical world around us in more ways than we will most likely ever know.
Joaquin and Boaz. The two pillars have been a symbol of an entryway into the unknown, both physically and spiritually, for as long as our ancient history has been recorded. From Samson collapsing the two pillars and bringing the ceiling down upon his captors, to the mighty Hercules, marking the end of the known world by splitting a mountain to create an opening to the perilous Atlantic Ocean. Many of the old cathedrals have two large pillars aside an arched entryway leading into the church. Even modern buildings have this incorporated into their architecture, almost hidden in plain sight for those who have eyes to see. The first mention of the pillars, Joaquin and Boaz, comes from the building of Solomon's temple and goes into great detail, the materials used and their dimensions. Many secret societies mark entrances into their sacred places with two pillars, and has even a deeper meaning when looked at spiritually. From the ancient tarot card murals to modern art of secret society members, the two pillars have represented the path into the unknown and the paths one must follow to create the tree of life. Ancient alchemical text, the Kabbalah, Egyptian hieroglyphs, all the way back to the oldest Sumerian tablets mention the tree of life. The Mayans, Incas, Aztecs, Norse, Kemetic, and Celtic, just to name a few, all have their own tree of life mythology. The tree is meant to represent the Sephiroth, which are the realms that create this place we live. As you can see, they all have a very similar, if not identical, layout for the path to enlightenment. The two pillars create an opening, or a third pillar to ascend upon after death. You can see from these Masonic drawings that the third pillar in the center create a stairway, or a ladder to ascend upon. Now we will try to apply this to the earth we live upon, and how its magnetic field could be created using two pillars, which in turn creates a third pillar, or maybe our magnetic North Pole. When two opposing magnets are placed next to each other, a third magnetic pole will be created in the center. The magnetic field of Earth that we are given is in a four-leaf clover pattern that centers at the North Pole. The ocean tides also seem to follow this pattern. When you place the two pillars correctly, one can create the same magnetic pattern we are given. So the question is, do we need a magnetic mountain at the North Pole, or is the ever-changing magnetic field we measure created by other means, which are hidden in plain sight?
The movement of the planetas. Humans have been studying and documenting the luminaries and their paths since before writing began. Claudius Ptolemy, an ancient Greek, had over 900 years of observations to reference before Christ had walked the earth. He believed the earth to be at the center of the universe, with the sun, moon, planets, and stars all revolving around it. This is known as the Ptolemaic model and was considered the model of the heavens for over 1,300 years. Not until astronomer Tycho Brahe, born in the 1500s, came up with a model using newer, more accurate measuring devices. In his model, the Earth was still at the center, but now the planetas moved around the Sun as it circled the Earth. Soon after, the heliocentric model was fabricated and the geocentric model was set aside by most astronomers. Today, we look at the luminaries with opened eyes, now above a flat, motionless plane, and new questions arise. What causes these movements? Is there anything in nature we can observe that can recreate the paths followed by the planetas? Looking into magnetic field lines has brought forth some amazing similarities. Now, we have not measured and documented these motions for ourselves, and have found many that contradict each other. This is the path of the different wandering stars above our flat plane in the Ptolemaic model. They are actually all stacked upon each other, never traversing outside the tropics of Cancer and Capricorn, but are spread out in this animation to show their paths without overlapping. When looking through a ferrocell, using different numbers of light sources, we can recreate these motions' path with a single magnet. No matter the true patterns, they all have similarities in all the models we find. The real question is, with Newtonian and Einsteinian gravity never proven, is a magnetic property the answer to what directs the paths of the wandering stars?